Ladies and gentlemen, we are now in opening ceremony. Please rise for national anthem, Negaraku. Ladies and gentlemen, please be seated. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a good day to all. I'm Nufara Ain, your MC for today. Selamat datang, welcome, and welcome to MAHSA International Technology and Engineering Conference 2023, Mi-Tec, organized by Faculty of Engineering, Built Environment, and IT, MAHSA University. Ladies and gentlemen, members of the floor, Mi-Tec 2023 aims to bring together academicians, researchers, and industrial professionals from all over the world to share their experience in the field engineering and technology. It provides a platform for researchers, educators, and students to present and discuss the most recent innovations, practical challenges, and solutions adopted in their fields. With the theme Digital Transformation and Green Technology towards IR 4.0. So to begin this event, we are pleased to have Yang Berbahagia Professor Datuk Dr. Ikram Shah bin Ismail, the Vice Chancellor for MAHSA University, Yang Berusaha Associate Professor D.S. Dr. Iman Farshi, the Dean of Faculty of Engineering, Environment and IT of MAHSA University, Yang Berusaha Mr. Kasirajan Kasipandian, the Conference Chair for the Mi-Tec 2023 MAHSA University, all invited keynote speakers and all respected guests. Distinguished guests, ladies and gentlemen, without further ado, I would like to call upon Dr. Rusdi bin Matsong to recite the Dua. Please welcome.
استغفر الله العظيم الذي لا إله إلا الحي القيوم وأتوب إليك. إلى حضرة النبي الكريم مصطفى رسول الله صلى الله عليه وسلم كرام الفاتحة. بسم الله الرحمن الرحيم. الحمد لله رب العالمين. إياك نعبد وإياك نستعين. اهدنا الصراط المستقيم صراط وقال ربكم ادعوني استجب لكم. اعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. اللهم إنك خلاق العظيم، إنك سميع عليم، إنك غفور رحيم، إنك رب العرش العظيم. Praise be to Allah, the Lord of the worlds. Peace and blessing upon our Prophet Muhammad sallallahu alaihi wasallam and his companions and those who followed his example till the judgment day. Allahumma ya Karimu ya Rahim. On this blessed morning, in conjunction with the MAHSA International Technology and Engineering Conference 2023, We beseech thee and grateful towards you, Ya Allah, in favor of all the infinite blessing to us, your humble servant, to live in a safe and prosperous life. We seek your blessing for flawless progress of this event from the beginning till the end. We seek your guidance to steer clear of events that would detrimentally affect the program of this event. Ya fa'alu lima yurid, Ya Latifu, Ya Rahman. Please bless to greatness, peace, glory, and prosperity. Make us your righteous servants that followed your commands and neglect the sinful act. Ya Allah, please forgive us for our wrongdoing. Ya Munzil al-Barakat, bestow peace to our beloved country, Malaysia. Preserve us from any threat and disaster. Bestow passion in us in order to face the upcoming challenges. Please accept our deeds and please reward us accordingly. ربنا عليك توكلنا وإليك أنبنا وإليك المصير ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين.
Thank you, Dr. Rusli, for the dua. Distinguished guests, ladies and gentlemen, next, let us all welcome Yang Murshid, Associate Professor, TS Dr. Iman Farshi, the Dean of Faculty of Engineering, Built Environment and IT, MAHSA University, for his welcoming speech. Please welcome.
Good morning, all. Very welcome you to our conference, MAHSA International Conference of Technology and Mi-Tec 2023. So we are very glad today that we have our Vice Chancellor, Dr. Ikram, and our great speakers and guests from out of MAHSA and also other countries, India and so on. And very glad that I can see a number of our students and lecturers joining today. So in conjunction with the many plans that we have to develop our ideas in regard of IR 4.0 and green technology, as you know that we are very closely work to develop this Eco Village project, which is all related to IR 4.0, and we want to apply IoT, AI, and other green technologies projects in this project. So today I'm very glad that most of our colleagues in MAHSA and all around the world, they joined for this conference to share the knowledge, to hopefully develop more greater projects than before. So this is our first physical conference for 2023. So it's a very good experience. Of course, we had some kind of hiccups today. Our colleagues also from India are still not arriving in conference. But I really hope that everyone enjoyed today's conference. We learned something new from each other. And by this sharing knowledge, definitely we can develop the projects as we requested and as in line with the Faculty of Engineering, Field, Environment, and IT, MAHSA University. So I wish you all the best, all the presenters and participants for today's conference. Once again, thank you for joining us and have a nice day. Thank you so much.
Thank you, Prof. Ladies and gentlemen, now let us welcome Yang Berbahagia Professor Dr. Ikram Shah bin Ismail, the Vice Chancellor for the MAHSA University, for his opening speech. With all respect, please welcome Dr.
Thank you, MC. I thought when you put the slide there, your EMC is your qualifications. That's your function today. Okay. There was a lot of E, think of engineering. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm very happy to be here and welcome to the third MAHSA International Technology and Engineering Conference, Mi-Tec 2023. It's organized by the Faculty of Engineering and Built Environment and IT. Mi-Tec 2023 aims to bring together the academicians, researchers, and industrial professionals from all over the world to share their experience in the field of engineering and technology. It provides a platform for researchers, educators, and students to present and discuss the most recent innovations, practical challenges, and solutions adopted in their fields. As mentioned by Dr. Iman just now, this is conducted face-to-face for the first time since the end of the pandemic, and I think Dr. Iman and team has done a very good job. The list of speakers and topics covered are very good. And the theme for this conference, again, is digital transformation and green technology towards IR 4.0. This conference is to encourage research and innovative ideas that focuses on digital transformation and green technology towards IR 4.0 in the field of engineering, electrical, electronic, mechanical, and information technology. The topics of interest for submission includes, among others, Internet of Things, renewable energy, machine learning, robotics and industrial automation, manufacturing, smart materials towards IR 4.0. We have several eminent speakers for this conference. I would like to welcome, but unable to, our guest speaker, Dr. Dharmesh Jaichandpai Shah from Sankalchan Patel University. So he will be here anytime now. And also our other keynote speakers, Dr. Shailesh K. Patel, also from Sankalchan Patel University, still at the airport. Still. Engineer Dr. Xiao Chun Lim from MMU, Dr. Muhammad Arkam Cik Munaim, actually he's an adjunct professor at USM, also CEO of some company. Okay, but I look forward to his talk. It's a very interesting talk. And Mr. Zan. And finally, I would like to congratulate the department and the organizing committee under the leadership of Dr. Iman for organizing this very good, very interesting conference. And I wish there'll be a lot more students coming in to hear the talk, because this is a rare opportunity. We have speakers from overseas and eminent speakers from local engineering faculties and firms. And I think it's something that a lot of us can learn from. And finally, I wish all of you a fruitful discussion and a successful conference. Thank you.
Thank you very much, Dato, for the speech. Okay, so ladies and gentlemen, this is the QR code. In order for today, we have a conference Mi-Tec 2023, right? So if all of you interested to follow, okay, please scan the QR code to get the program book and also the abstracts for today's conference. Okay, ladies and gentlemen, I would like to call upon my colleague, Ms. Altira, to continue with the keynote speech.
Thank you, Ms. Farah. Ladies and gentlemen, we will begin our event today with the keynote speech by our keynote speaker. The first keynote is going to be delivered by Adjunct Professor Muhammad Arkam bin Munaim from University Science Malaysia. Muhammad Arkam bin Munaim, working as Adjunct Professor, University Science Malaysia, he studied Diploma Electrical Engineering, Power from University Technology Malaysia, 1998, Bachelor in Engineering Electrical, University Technology Malaysia, 2000. Master Building Technology, University Science Malaysia, Penang, 2010. And Doctor of Philosophy, Energy Conservation, University Science Malaysia, Penang, 2014. Is registered professional engineer Malaysia since 2005 and a fellow member of the Institution of Engineers Malaysia in 2020. He holds 3 competencies as a SPEN qualified person, National Water Services Commission for Water Supply and Sewerage Treatment System, a Certified Energy Manager registered with Suruhanjaya Tenaga Malaysia, and a Certified Construction Project Manager of Construction Industry Development Board Malaysia, CIDB. Currently, he serves Engineering Accreditation Department as EAC, the DAC panel, and appointed as committee member of Application Committee in the Board of Engineers Malaysia, BEM. He is a technical expert of the Green Technology Financing Scheme from Malaysia Green Technology Corporation, Industrial Advisory Panel for University Science Malaysia, the Ministry of Youth and Sports Malaysia, and University Malaysia of Computer Science and Engineering in Mumbai. He is a registered national industry expert with the Ministry of Human Resource Malaysia. He secured more than 20 membership and affiliation includes from Board of Engineers Malaysia, Institution of Engineers Malaysia IEM, Institution Electrical and Electronics Engineer MIEEE, Institution of Engineering and Technology MIET, Asian Engineers Register, Asian Chartered Professional Engineer. I would like to invite Adjunct Professor Muhammad Arkam bin Chinain to deliver his talk with the title Potential of Fiber Optic Lighting for Interior Illumination in Malaysian Tropical Climate. With all respect, please welcome.
Terima kasih Cik Mus Majlis, our VC Vice-Chancellor Datuk Professor Ikram bin Ismail, our Dean for the Environment Faculty, Iman Fashi, all speakers coming from Malaysia and also overseas, and all participants or members on the floor. So again, my name is Muhammad Arkam bin Chinain. So regarding to this theme today, digital transformation and green technology towards IR for consumer. So let me walk and also thank you. Okay, thank you. All right, so this is our theme today, digital transformation and green technology towards IR for consumer. I'm very glad to be here. Thank you for inviting me, having me today for this sharing session. And regarding the topic today, some introductory of myself. You got my numbers there. Actually, you got QR code as well to scan to get more information about me. So everything is been there in my website. Again, this topic is actually on renewable application of innovation regarding fiber optic daylighting. We'll go through the details for the conference today. Potential of fiber optic daylighting for interior illumination in tropical climate. And I would like to firstly, I think our Prof. Dr. Architect Abdul Malik is actually my supervisor for this project. But he's not be able to be here today with us. But it's okay. So hopefully we can get something for him. The keyword is fiber optic daylighting Malaysia. This is what you can find from the Google. If you find, if you Googling it, so there's a keywords there. So from there, basically, all the top five in Google is actually our work from 2014, 2013 is from Mali as well. So a lot of detailing if you want to go for details. So there will be information there if you really need to go for details later. So let's start with some historical part of daylighting. So we've been proven that Vitruvius, I'm not sure if it's the pronunciation, is the first architect and engineer who's doing this kind of implementation of daylight been recorded in our history back 2,000 years ago. So it's not new. Basically, we just go for the innovation and implementation, but the eldest history that we can go is actually from here. So he is actually the one who introduced the technology or the technical, or the theory behind of this daylighting system. And in our practice, fiber optic daylighting is one of the active solutions regarding this principle of daylighting distribution. There are a lot of things related to the daylighting. Actually, it's been everywhere. Everybody can see it quite everywhere. So one of the ideas is through the passive daylighting distribution. We got two main criteria. First of all, from the top one, we have light shelf. Some pictures is actually prepared later. We have skylight or source light well, roof monitor, and atrium. It's a very common here in everywhere, atrium, or we name it as atria. It's a part of the strategy to get the daylighting into the building. And from the wall, we can, of course, we have doors, windows, regarding to the shape, type, size, and also how it been faced. So it's part of passive daylighting strategies. So the importance of daylighting we'll discuss later. Why? We need to go for daylighting. So top and wall is the common one, but we have also an active solution through solar panel lighting. There's a Himawari project before. I also showed the pictures, and also light pipe. It's quite common, light pipe, if you notice, I'm not sure. So some of the engineers or maybe building technologies, or we as a technical man, we usually look into this kind of innovation. So light pipe is one of the solution and been widely used as well. Been widely used, but I can say it's very minimal. Minimal in terms of why we want to go for that light pipe. And another one that we can go is actually the fiber optic daylight. If you know, the fiber optic is a cable made of the glass or silica, so it actually can transmit lights. So from that light, is it possible to get it into the room to be part of the illumination system? And the source of light is actually should be coming from the sun. So that is the actual ideas. How to bring the lights to the core of the building by the sunlight, the sunlight through the core of the building through this innovation. So some of the theory behind, I don't have to read, but you can read by yourself. Thank you, coming. So these are the principle of daylighting strategy. How we can distribute light through two main strategies, which are passive and also active. So these are what we can call as passive, and this will be the active solution. And this some of the features. I think light shaft is quite common. It's bouncing the light from the top of the windows, and windows will be part of them. Bouncing to the interior, skylight. Commonly, we can find it quite common here in the bathroom there. So we get skylight. Is an innovation to get the light from outside. But the problem with the light of outside is actually it comes together with the solar radiation or the heat. So the heat also part of the solution that we need to solve before we go for useful light. So that useful light is normally the sunlight comes with three main important elements, which are the light, the true lights. Secondly, the solar radiation. Why the third one? Why the third one? The heat. The heat. So it comes together with three minimum elements, even though they got a lot more basically. But these three are very commonly discussed. So what we can do is actually to separate the heat and also the solar radiation to get the useful light. So we have conducted this research in 2013 and 2014. So light well is a light well, telaga light well, and also the solar roof. But this is not so popular in our climate. But if you go for UK, so it's very, very popular. Very popular. Because why? They're facing to the south. From UK side, the sun is actually from that south. If you see the solar path, you can see that the sun is actually from the bottom of their side where they are positioned. Meanwhile, here in Malaysia, we have this sun above our head. So there's an equinox every two times a year, where the sun is precisely above our head, so that we can see our own shadow just here, not here, not here, not there. So it's become the equinox time, where it happens about 2 times a year. So that is where our country or our climate is basically blessed with that kind of situation rather than in the UK. So that is why in the UK this tow roof is very, very popular, because facing to the south, you can see the light coming from the sun from the south side. Same goes to the far southern earth, for example, New Zealand. So they have lights facing from the north, from the sunlight. So actually, it is more common to see there in that kind of climate. Because if you put in our climate, we cannot see sun in this area, because our sun is really from the top. That's why atrium is more popular. because we can see the sun easily driving from our top. So roof monitor is one of another concept or theory to get the sunlight. So where it's actually common in Malaysia, I can see a lot of here is also in our housing development, even in Cyberjaya, we have it in Putrajaya. Roof monitor to get the light enter to the building or to the core of the building by the implementing the roof monitor. And atrium is very popular, I think everywhere. I'm not sure what is the nearest shopping complex here, but it's supposed to be a part of the blended design or architecture to minimize the usage of electricity for the big area like this. So some of the examples again. Okay, let's go for this. So atrium, roof monitor, lightweight, light shelf, skylight is quite common. It's quite common. But by this explanation, maybe you need to go. What is now we can talk about solar light tube or maybe solar through fiber optic electric. Okay, why? Because it's been discussed or been examined and so been what we call that, investigated that our lighting electrical power is consumed about 13 to 43% of our electricity. So look at our auditorium now, coming from the artificial light there, artificial light here. So even in daylight, we need still to on the lighting system, and we still have to use the electricity to lighten up the area. So it's very common. Everybody, everywhere is doing the same thing. In fact, our home, our house also doing the same thing. And our offices, all these manufacturing, you know, the shopping complex, you name it, everywhere. We need to switch on our lighting system during the daytime due to the presence of the sunlight inside the building. So it's quite common. It's not wrong anyway, because it's part of our comfort. We need to have sufficient lighting. So these are some of the research made in 2006, 2011. I'm sorry, it's quite, I mean, old research, but this is my work in 2013, so we need to understand that as well. I don't look into the latest references about this, but it's quite typical to see these figures. 13 to 43% of our lighting will go to lighting. Our electricity consumption will go to lighting. So that is the thing that we need to understand now. It's very promising. If you can go for this electricity or saving through lightings, it's very useful thing for us to get the energy efficiency from the building. Yeah? So these are some of the research made in 2006, 2011. Okay. Some of the background, so I mentioned here, 13 to 43. Artificial lighting is a second major source. The first one will be cooling, the aircon, of course. Second will be cooling in Malaysia, and in the other climate, there might be the heating system, HV, heating, ventilation, AC, aircon, ACMV, yeah, HVAC. Okay. You're good. So second major sources. So lighting will become second. For normal building, if you go for industry, it might be different because industry will consume a lot of electricity from their machineries or their equipments. So this is from Energy Commission in 2011, second major sources. So if we can reduce it by whatever means that we understand through, I'm very happy to know that we have what we call it just now, the building. Eco village. Eco village is a building or is
empathy
area, village area which we're going to make like a small container.
I see. Okay. I think this part of innovation or maybe great work by our VC as well, the MAHSA management, to have a showcase on that. Hopefully all this can be implemented. I'm pretty sure that our Dr. Malik will be very able to get us on this. He's very passionate in this kind of things. Okay, so if we know that the opportunity for us to get the saving through the sources of electricity due to the daylighting implementation, so why not we go into detail so that we can understand how we want to do it in the real life. Okay, now introduce you. This is light pipes. I think maybe most of us have seen it. There has been implemented in few places. one of my project in Plus also implemented it, but I can see that we are in the stage of just trying and error. We can say, or just to meet the minimum requirement for some other purpose. For example, we want to meet the innovation mark from GBI, for example. So they put it inside, but the implementation is not, I mean, the actual implementation actually can be still improved. Because why? Sometimes we target the points coming to our GBI status, part of the innovation. But in real life, it's very useful. If you can put it into the very serious manner, it's very useful. So this is the light tube where you can have this dome externally on the roof, either flat roof or pitch roof, and then the light will travel through this cylinder or tunnel and be lighted up into the space that we want to. So this is part of the innovation through this light tube coming from the external light to our internal or interior room space. So this technology have some limitation. For example, they can travel up to certain lengths only, certain length, because light is actually bounced from this internal what we call it surface, and it will get some maximum length. It can be useful. For example, it can just walk 1 or maximum maybe 1.5 meters. 1.5 meters. You cannot travel so long. That is why the idea of fiber optic thing comes to counter. So these are the technology behind this solar tube. Consists of small glass or plastic dome shape mounted on the roof that collects sun and direct into polished aluminum tube that extend from the roof to the ceiling. Solar tube skylight is the loss of sky light from the greatest mouth opening. Much small standards can reduce the amount of heat solely from sheer aspect 11. So this is what you can see from the outside sun coming through the dome in the external roof and traveling to the ceiling space. Same goes to here from the solar, from the roof side. This is actually the dome coming, traveling and up to and lighted up the space under the roof, not above the ceiling. So this is maximum can go about 1.5 meter on, about 6 feet to 8 feet on. This is the maximum. You cannot travel more because it will be deteriorated and also been. So that is why to replace this atrium is one of the best one. But atrium having another limitation because it can be done in the space where the atrium is our level, but it cannot travel up to the. So these two technologies, when talk about the first passive design on this solar lighting, with that kind of limitation, they came out with this kind of technology for solar tubing. So you can tube, still got again more limitations, so they go for this one, solar lighting memory. So where they've channeled the solar lighting, cannot say what is the collector or the receiver to be used as a lighting, and they channel back to the interior building. It's a system that efficiently collects sunlight to be used as lighting. This will be using solar fiber optic as well. So this is the lens, concave lens. So we've been channeled to the fiber optic cable and we travel into the building. So the length is more in terms of the length compared to the solar tube is more far you can go, but still having their own limitation as well. So we'll try to discuss about limitation later. So here, some sketch out how we can have this solar receiver travel into bundle fiber optic cables into the building for interior illumination. This is actually my own drawing. I think you have to forgive me on that. And windows actually will we have limitation. Windows or even rooms, the doors having its limitation to allow lights coming. It's about 8 to maximum 12 foot, about 4 meters only. So the light from the external envelope of the building can travel up to 8 to 12 foot only. So if we can go something that deeper, so that we can get more, practically used for that light to be traveled inside the building to the core of the building rather than to the side of the building due to the building envelope. So building envelope is one of the things that very possibly to get that daylighting. Same goes to the roof, but they has the limitation. I'm looking into the deep inside, so that we can bring the sun light deep into the building, so that we can bring it to make illumination inside our building. The lighting is not possible through window. This is possibly through so fiber optic daylighting, also named as remote source daylight. And you can also Google remote source daylight, is actually part of it. So now we have explained to you, first of all, the passive design through windows and doors, or I mean the roof and the envelope. Secondly, on the passive active design, for example, just now we looked into this solar tube, so Himawari project, and this one is actually this. We are coming through this solar fiber optic light through for interior illumination. So hopefully you can follow me. There's some of historically background in there, and also what is the theory or the implementation that we can improve on that lightings. For example, we have this passive and also active. We have wall, we have roof, passive design, atrium, light shelf, sawtooth roof, and whatnot before, and then goes into the solar tube. It's quite promising, but some other limitation. And then go for a Himawari project, one of the fiber optic projects. Later on, go for this. Now we try to look into what is the possibility and the potential of fiber optic daylighting in our climate. Okay, some of the research made bringing the external elements into the building. It's not new, basically starting from 2000. Our Professor Azmi Zain from UITM. So she's actually looking into how type of window and also shape of window. Later on, Pravani coming with a lot of information from the meteorological department. I think she have been discussed about our weather condition for more than about 30 years by now. So it's very powerful reference. We want to know about our meteorological things, or what we call references regarding the solar radiation, regarding the sunlight. 30 years of exploration by probably is very good reference for all of you. Gravimetry in 2002 talking about fiber optic, how the methods of bringing the external luminance to the building. 1997 we're talking about window and also shape, type, and also light shaft. And then from Azni, window and light shaft, the shape of windows. Grass and Battery 2002 in the US, fiber optic. Garcia Hansen in this from Australia, fiber optic. Curti from US talking about window and window, still window. And then this Krolinger from US also talking about this all light shaft, skylight, sort of roof light, well, also roof monitor. And then Hen and Kim from Korea, shape of window as well as the fiber optic. Chiras from the UK, also from fiber optic. Said from Sudan talking about windows, and Wong and Yang from Hong Kong talking about the fiber. So fiber optic research been there since 2002 from Chris and Patrick, but they are most likely into either simulation or theoretical review. Theoretical review. We did our part in put it into the implementation of empirical result, so that we get the empirical result through this research. Okay. All right. Long paragraph there. We try to go to the important things there. Application of fiber technology was telecommunication, as mentioned, whereby information was transmitted by light signal. Fiber optic has also been used in many other applications, such as medical imaging, as a specialized lighting for dentistry, microscope, and blah blah blah. Fiber optic is used to sensor to measure pressure, temperature, and humidity, and transmit light from one to another. The application of fiber optic has flourished the lighting medium for decorative. One is decorative lighting. It's very sold in our even your Shopee also have. Decorative lighting, you know, is a colorful LED light. So they have linked into the fiber optic. They can use it as a as a as a as a decorative light, something like that. If it's widely used in what we call that swimming pool, because less hazard due to the normal lighting, because there is no cable there, no electrical cable. It's just a silica or plastic cable running through the swimming pool, being projected by one light source. You can change the light source by using the LED technologies. It's very simple there, but it's less harmful because nothing can harm you in terms of electrical hazard. There's no electrical hazard at all because everything is using the plastic inside that pool. Nothing to. This is thing that we can explore. There's a market selling of all of this, but I mean, the swimming pool is still using the normal lights, waterproof PN, what's PN? IP, sorry, ingress protection 6-7. It's very high protection, or maybe more than that. But it's very still talking about people in the pool is quite hazardous. But change to the fiber optic is very, very safe, 100%. Many advantage of lighting system. This is from Ifan Suyong in Hong Kong. The low loss solution to optical cable because the structure of the cable is one of the advantages. However, the major disadvantage is first you need to be on time. This is the main terms or main word here. Point to light. Point to light is the precise light being concave or being directed to the fiber optic cables. You can see the fiber optic, how big is it? The diameter. For example, let's say we have 5 mm. For example, how you want to point the light straight to the concave lattice by knowing that your sun is actually moving from one direction to another direction, and that's not in the same path. Sun is actually coming from the different path, you know, the angle, and the receiver need to precisely attract and get the sun to get it concave right to the fiber optic cables. So it's very, very major challenge there because you need to detect the sun and then make it align to the lens. From that lens become a concentrated light. So that concentrated light is actually the pointer light. Goes into the fiber optic cable and bring that cable inside your building. So there is the whole what you call that challenges for that. And there was the whole challenges for that. So the pointer light is the main things here. When talk about fiber optic daylighting, pointer light is the main challenges. But if we talk about other type of fiber optic LED lighting, for example, fiber optic lighting is quite simple, but not widely used other than that kind of decorative lighting. Because why? Because we can still get the lighting straight away to the cable or to the energy or to the lighting source. So it's a defeat the purpose. The main purpose is to bring the light through the remote source into the building through that transmission. But if you cannot get it by having the pointer light, so defeat the purpose. Cannot go anymore. So that is why another interior illumination studies from the fiber optic itself. These are 4 areas: heat, capture, transmit, and distribute. Heyman in 1990s talking about the modeling and simulation on to transmit the light. How to transmit the light from outside through this fiber optic cable. Grace and Betty also simulation. Ergun and Kandili from Turkey, capture and transmit, modeling, mathematical, simulation, computer by Sansoni from Italy to capture the light. Han and Kim from Korea to capture and do the empirical for the first time. The empirical done by Korean is on the lab size, lab skill, Chen and all is from UM, Malaysia, modeling and mathematical. Hamza is also from UM Malaysia, literature, the review. Patrick from Canada on the modeling, how to distribute the fiber optic lighting through these things. Ifan and Soyeon from Korea on heat and capture. So that is why heat will come together because the energy of lighting comes together with heat. So same goes to this lighting as well. You touch on the surface, this can still feel with it. Ifan and Soyeon from Korea, Sound is all from Korea, talking about capture the light in empirical modeling. And Sapia from Italy is talking about the capture and also distribute light through computer simulation. So the lens of empirical studies been made through whatever research from 1990 to 2013 at that time. And that is why when we Google that in fiber optic daylighting Malaysia, that's where we can find our works will be top 10 basically, because there is no such empirical study been made before this year. Okay. Again, daylighting component of FOC, free of charge. No, actually fiber optic cable component is based on the recommendation made by STAR. So this is all recommendation by all frequency researchers. Need to have three main components or three main elements, which are the receiver from this personal lens, sun tracking system. This is where we need to improve the algorithm to sun track. Another issue. We have sun tracking solar panel in KLI. You notice it's facing to the sun from start day to the end of the day, but it's not precisely following the sun path because it doesn't have to. It's just follow by timer and also by angle to tilt from one angle to another, just to get maximum from the morning to the evening, to the end of the day, I mean to evening. Make sure the panel is following the sun path, following the sun location or sun position. But the sun is actually not coming from there every day. It's actually rolling from the north, coming back to the south, rolling back to the north, coming to the south. So actually you cannot find it's going into the point for light if you get a problem. So solar receiver with sun tracking system also listed by UNO. This is how they selected fresnel lens. And secondly will be the optic cable, and the material will be the plastic acrylic. The material, the suitable material will be the plastic acrylic, 6 by 10 meter. See the numbers of the transmission is now become 4. Starting from 1.5 from our solar tube, now it can become up to 10 meters. Plastic acrylic type of cable transmit the light from the receiver. It most commonly used in fiber optic daylighting system. Tolerable losses. You can still have a losses, but it's very minimal, very negligible. Reasonable cost and also applied by these other researchers. Diffusers, another plastic acrylic is chosen due to two materials compatibility that connecting the cables diffuser. However, the very few researchers are okay. There's no much problem on that diffusing things because we have a lot of reference to go. These also having their own diffusers. I mean, the artificial light having their own diffusers. So we don't have problem to diffuse the light. The only problem how to catch the useful light and transmit it into the building. So the main or the biggest problem is actually to get that point of light. Other than that, it's quite simple. Okay, but to get that point of light, it comes with few criteria. For example, you need to be precisely mark on the position of the sun, wherever sun is going. Because sun is actually not coming straight direction. It's actually roll from one northern side back to the southern side, coming back to the middle side to get the equinox and also whatever their movement. So that is the main challenge in our research. Okay, all right, components. So these are, I'm introducing you the how it looks like. For example, this one will be the receiver. Follow the sun over the day to collect lights, optical design using lens to capture and concentrate. This is the optical concave lens. Small amount of sunlight into the fiber optic will immediately transfer to the building. Receiver power 10-watt adapter because they have the electronic sun tracking circuit inside the receiver. So involve electronic circuit. So if you know, if you involve the electronic circuit, they got this kind of sensors. Things need to be recalibrated on and on because there's no such thing as a permanent sensors. I need to recalibrate on and on, maybe 1 year, 2 years. I've been in this research also, we have made one calibration. With the cable up to 10 meters, 6 solar fiber cable are attached together in this bundle, a 10-meter length from the receiver to inside the building. The spotlight retaining the full spectrum of light cables are thin, flexible, and made pure silica, which is common in fiber optic daylighting system. So the bundle, this got 6 cables inside one main cable, and also the diffuser. I said we don't have much problem in diffusers. A lot of things can be done. It's very simple as well. Just replace the diffusers based on the finding that you can get. So the main part will be these receiver parts where you need to have this concentrated optimum amount of sunlight to the fiber optic. This is very important. If you don't miss that, you don't get that internal daylight. You won't get any lights into the fiber optic cable. So this is the real, the equipment. This is the cable. This is my own hands. This is the diffusers, and also the receiver. These are all the details. I will share the slide later. The slide is really shareable at the end of the presentation. I put a QR code for you to download directly. So I have to don't have to go detail on this. So light output signal about 550 lux at 100,000 lux outside, measuring from 800 mm from floor level working plane. Okay. So that is the strategy to measure the lights. It's actually 800 mm from the working plane. It's a table height. 550 lux. 550 is very bright. It's very bright. Normal office is about 300, or you can work also about 200. The pathway or toilet is about 100 or 50, 75. External about 750 is okay now. So this is how we measure the lights through this output. Other than that, it's all about the specification of the detail that we want to go. This is the measure weight, blah, blah, blah. So we have this operating temperature as well as the power consumption for the adapter, about 10 watt only, because you need to go tilt and also this direction. So by a 4 direction, this direction as well as this direction. So even though they move this way, but basically not the same direction. They slightly take to this direction to get back and come back to the morning in the first place, and then get to track again the sun. So every day we need to go for to catch the sun due to this research. So that is major challenge. Here the building, we use the actual buildings. We are fully enclosed. There's very totally dark. There's no other possibly this. We have this what you call that skylight, just to compare previously, but we have closed it. And then this is the scaffolding. We have scaffolding and put our receiver here, and the cable optic is here. There's a computer box. Other inside will be all the parameters and also sensors. Here, close up the building. Basically, the building. This is the facing to the east. This is facing to the west. This side is facing to the west. So building facing east. This is Penang, USM specifically. You know, this is Jambatan over there, Jambatan Pulau Pinang. And then HPP is very turun je boleh nampak sebelah sana. And then this is the mainland. This is Penang area. So matahari from there, that direction coming through this direction. Okay, here the close up of the building where the receiver, and I have mini meteorological station. Even the mini, we have about 26 sensors altogether to capture about 5-minute intervals. Meteorological station, and also our receiver. Then we have this fiber optic cable. This is the total dark room. We have no other way for light to go in. And this is close up. This is the apa tu?
Wind sensor. Wind sensor.
Wind sensor. We got this humidifier, solar radiation, and blah blah blah. So everything's here. And this is the receiver. And construction material is normal construction material. Nothing special. Cement render, plastic, plastered brick wall, metal deck, gypsum board, wood, painting, no window, normal plywood, no painting anywhere. And this is interior. This is interior where we put our sensors and also our other sensors, temperature and humidity, plus this lux or illumination sensors. Okay, these are all measured by tools first, just to make sure the positioning of the sensors. This is myself, quite thin at that time. I put quite a lot of weight since this that is a lot over to do sampai I jadi kurus. So sini some of the hand tools that we have bring it to the sensor, to the building. And also we have this temperature surface. I think this is surface temperature sensor. Wind and lux meter, surface temperature sensor. This is also lux meter. And we have also our the humidity sensor as well as the temperature. Okay, this is also myself into this meteorological station outside. The final configuration of optimal approach for working. Okay, again, very long. Fresnel lens type of solar receiver with sun tracking system is also selected by other researchers. What we use because it gives the good performance at a low cost. So this our final optimized fiber optic system that we put into our research. So receiver, station, and myself, and also inside this is what we have explored, and then we put it into receiver facing to the sun from that direction, from the mainland, because it's a Penang Island on the east side, west side. So matahari from that side, morning sun. This is receiver from the evening side. This is receiver on the noon side, because you can see it facing up to the north, up to the straight to the sky. This one facing to the west. This one facing to the east. Sebab matahari baru timbul sini. This one matahari sudah nak terbenam. This one is on top of our equatorial line. Okay, here is the cable transmit from this receiver into the building. These are cables, and we have put our. You can see this is actually our surface temperature. I'm not discovered by the surface temperature by now. Internal light diffusers is a common diffuser that we use. Come together with that package. So basically, it's very. We don't have no much problem on diffusing side, as I mentioned. Okay, illuminate sensor outside, solar radiation outside, humidity, air temperature, and also humidity sensor is all in the meteorological station. Just one more about the wind just now. Okay, top left, blah blah blah. Okay, done. This is for outside. This is for inside. We have this lux meter. This one will be the humidity. Sorry, this is humidity. Sorry, this is the temperature. This is humidity, and this is the surface temperature. So we put about 26 sensors altogether inside that research, just to see it promptly capture the output based on the selection. Okay, this is a computer box. We need to blend it into one data logger. So this is another part where we need to configure the data logger due to our own consumption, our own customized consumption. So this is data logger being customized to get this information coming from the sensors and capture it into our data logger system. Okay, here inside, and surface temperature, and the diffuser and the surface temperature. Other than that, it's all on the working plane 800 AM. Based on the consideration of the solar radiation and external lux intensity. So this is how we do the data saving and data analysis. Consideration of solar radiation and external lux intensity in data analysis also been conducted by Prof. Zain, Irfan, and also internal-external comparative analysis, just to compare what we can get from external and what we can get from the internal. Simplified comparative analysis implemented. It's a very simple one. In fact, I'm just using Microsoft Excel for this. There's no SPSS or these very powerful tools to use this comparative analysis. Meanwhile, investigate the environmental impact from the solar energy, followed by Gizi thinker, outline value of saving. Okay, this one is another issue. I've not discussed on this part. We got three objectives basically. The first of all, we want to know the potential in terms of bringing the light into the building. Secondly, we want to know the impact of the humidity and also temperature. And the third one, we want to know impact of this kilowatt saving, environmental saving, by using this thing. So we're not going to these two in our presentation today. Okay, this is the best part. We see the results coming from the actual data collection we have made about 1 month basically. During that equinox happened 1st April every year. 1st April every year. So what is it April? May, sorry. So this is area that we have collected. Moderate sunny. This is type of cloud from this MAT office 2012. So we need to understand the cloud type as well. This is how important to know what everything regarding to this weather things we work with internal and external illumination. So the weather type, we have moderate sunny, less sunny or hot sunny. So this one of the parameter that we distinguish, and also how the looks, how the cloud cover type and that during that duration. External measurement, lux average, external, and watt per meter square is the solar radiation. And this is solar radiation. This is the lux average outside, and this is estimated sky condition category by we have referred to Prof. Zain. Intermediate mean, overcast, intermediate blue, overcast, overcast, intermediate blue, and intermediate gray. So we got three types of main sky condition categories. Three types. Okay. Okay, so for example, 60 to 80 kilolux we consider as intermediate blue, 50 to 60 kilolux is intermediate mean, and 40 to 50 kilolux is overcast. This is from Prof. Zain as well. So Prof. Zain is very, very good reference. You talk about meteorological things, comparable to understand what is our condition is like. Okay, result on category 1. This kind of sky, blue sky. Sunny days with intermediate blue sky, and the percentage of occurrence is about 18% in Malaysia. So in Malaysia, we've got 360 masa. Berapa lama lagi? 5 minutes. Thank you for that reminder. Okay, about 18% occurrence yearly in Malaysia, going very fast. Here, these are the results. The blue one is actually the internal illumination, solar radiation, and also average internal illumination. Oh, sorry, external. I made my mistake here. External. Okay, so the black is actually the internal illumination. We can find the light is when the system is working, and it can capture light with this black dots. And 3 samples. First of all, during these days, 22nd of May, this is light on, it's off, on, off, on, off, on, off, on, off. Because what? Point of light. Point of light, and so one more thing is actually the cloud cover. When the cloud covers the sun, it's good for us. We are outside, but not good for this. You cannot capture the light anymore. And then off, this all off, and then go back to the quite stable because there is no cloud cover from 1 p.m. to 6 p.m. And then this another days as a sample, another day as a sample. Yeah, all right, I think that's quite clear. This is how the sky looks on the days, on those days. Clear, there's no cloud at all. I think a lot of us we don't appreciate this because we can have this every day. Yeah? But in fact, if you go for this kind of detail, you cannot find any single day with the same day. The parameter is very precisely changed by our what we call it, our creator. We cannot find any the similarity, even in this kind of research. You see solar radiation, humidity, lux level, and all those. You change one parameter, other parameter will follow to change. So this is what we can do. What we can find in the first very effective result that we want coming from this cloud of sky. Secondly, okay, this one I need to go fast. This lampu sudah menyala from outside. Here the diffusers and blah 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 lah. I got 4 minutes and a half. This is the pointer light. Pointer light into the fiber optic cable. Straight away can diffuse the light through the fiber optic cables. And this the second category. On the hot sunny day, which means sky, about 66% occurrence yearly in the city. There's now about 16. This one is 66%. So we have more exposed to this kind of weather daily in Malaysia. The data is collected about 30 years ago up to now. It's still being counted. So these are the results. Comparatively, from the first one, is a lot more off rather than on, due to this one, I believe, through the cloud cover off. This is on side. So there is actually the limitation of fiber optic cable daylighting system because it will on and off due to the sky condition, and precisely talking about this sun position without any cover from any clouds, and then the pointer light need to be established. The one, this is how the sky looks like. Pretty one, very cloudy. You can see because once cloud cover, they have lost the tracking, and they need to get back to track the sun when after a few minutes. So that's happening. And the third category, overcast sky, about 16% occurrence in Malaysia. So overcast, our cuti apa tu, tengkujuh, musim tengkujuh is about 60% occurrence in yearly in Malaysia. So these are the results. So there is more off than on, more off than on, more off than on. So basically, by this comparative studies, we know the implementation, the potential, how we go for this fiber optic cable to understand the overall potential. Okay, this is how the sky looks like. Very normal.
Cloudy.
In Lembah Kelang, I think in Klang Valley, petang-petang hujan. So usually the things coming in. Okay, I don't have to go through this, but it's inside our. This is the conclusion. 1 more minute. Fiber optic letting off about 21%, from intermediate blue sky off about 21%, on about 79%, 48% on for 55% off on the intermediate mean sky, and overcast is 40% on, 62% off. So mean to say that the potential of this fiber optic cable based on these three types of weather condition is about this. It's about this. So we have got 50 or say 80% chance to get that light during that hot sunny day with intermediate blue sky. But the problem is when it's hot sunny day with intermediate blue sky, we don't like it. Of course, it will increase another problem in terms of the cooling because very hot. So it's just an exploration for us to think there's other possible way to venture on this. Or I can say that optimized thing is more optimized interaction between these few categories of like daylighting. We can blend it together and put it into one optimized solution. These are 5 papers they published during that research. Our Prof. Malik is also here for all. I think here, and here, so here, and also here. All right. These are all the exhibitions. Myself, Survey Hello, we have also presented it in the UK because I've been there for some sabbatical leave. So the part of my research been presented there in Survey Hello, and this you can scan for the copy of your PDF slide if you want for to keep your copy. Okay, so I think that's all for my presentation. I would like to thank again our PC. Thank you for having me today for this topic. Hopefully, it can enlighten up your ideas to get how you can go with this kind of fiber optic daylighting system as a part of remote source daylight strategies to be blended into our other of our theories and also what we call that strategies to get the daylighting inside of it. So with that note, thank you again, our dean as well, all secretariat and members. Thank you so much.
Thank you, sir, for the interesting talk. I hope we will benefit from the talk. We humbly appreciate your presence and share your amazing knowledge with us. And with this, I would like to call Yang Berbahagia Professor Dato Dr. Ikram Shafiq Ismail, accompanied by Associate Professor T.S. Dr. Iman Farshi, to give the token appreciation from us to Adjunct Professor Muhammad Arkam bin Chibunail. Please welcome.
Ada lagi ya?
Thank you again. The second keynote is going to be delivered by IR Dr. Seo Chun Lim, Senior Lecturer, Multimedia University Malaysia. IR Dr. Seo Chun Lim received his PhD in electrical power engineering from University Putra Malaysia. He is currently a senior lecturer and the program coordinator of the Bachelor of Electrical Engineering at Multimedia University, Malaysia. Since 2018, he has been actively promoting awareness of electrical engineering standards among electrical engineering undergraduates by speaking at more than 20 universities to date. His research interests include lightning risk assessment, electrical earthing material, sustainable education. He is the national expert by representing Malaysia in the IEC TC81 lightning protection. He is currently the chair of Electrical Engineering Technical Division, the Institution of Engineers Installation AEI of the Asian Federation of Engineering Organization. As a council member of IEM 2021-2023, he is serving in the Activity Standing Committee, Admission and Practical Training Standing Committee, as well as Information and Publication Standing Committee. He is also the current principal bulletin editor of Jutra, a monthly publication of IEM. Back in November 2019, he is a professional electrical engineer registered with the Board of Engineers Malaysia, a professional HRD corporation. Certified trainer and is also trained in design thinking and visualization through freehand. Dr. Seo is a trainer in the field of lightning protection and is serving as an external examiner in an institution of higher learning in Malaysia. I would like to invite IR Dr. Seo Chu Lim to deliver his talk with the title Looking into the Sun. Please welcome.
Into the sun. Siapa nama Tino?
Okay, good morning, everyone. Yep. So how many minutes do I have? Until 11. Okay, can. No problem. And actually, I think I made the right decision to not to present on my PhD topic because from our previous speaker, he's very passionate. So it's good. I think I picked another topic so that I wouldn't be too passionate and overshoot the time. Yeah, PhD, we're very passionate, right? So, okay. So first of all, thank you, Dr. Iman and Dr. Ikram for gracing this event, and Mr. Kasi for chairing this event, and Dr. Moon as well. I'm not sure whether he's in, but he's the one who did all the communication. So thank you. My name is Xiao. Although I am a senior lecturer from MMU, but I am here not because of MMU, but because of IEM. So the invitation came to IEM, and I thought that maybe I can take this opportunity to maybe share a bit on a new topic, which I have recently found a little bit of interest in. Right, not an expert in it, but we'll see. So I graduated from UPM. Then I taught in Taylor's Multimedia University, and yeah, I'm in Multimedia University, Cyberjaya. The rest is just as what you can see. Usually I start off with this slide in any my presentation just to introduce myself. I'm into trading, mindfulness, yeah, etc. So that's my number. If you need to contact me, okay, feel free to take down my number. I'm also with the EAC panel. Yeah, and I'm also in IEC, right, International Electrotechnical Commission. I'm in the Lightning Protection Technical Committee. So yeah, feel free to search me up on LinkedIn. All right, hope to see some connection after this. All right. Yep, that's my head talk. Okay. Anyway, yeah. So I'm the current chairman of IEM Electrical Engineering Technical Division. I think all of you know who is and what is IEM, and I'm in the Electrical Engineering Technical Division. I'm currently serving my first term and going into my second term as the chairman. All right. So IEM we do a lot of activities. We organize a lot of talks, seminars, right, in these areas: electrical installation, energy, transportation, electronics and telco, biomedical and healthcare, explosive environment. But we focus on the electrical side of things, right? So because our technical division is electrical. Okay, so that's why you look at this, you can see that any of you are E&E student? Yeah. So if you're an E&E student, you have a lot of opportunities waiting for you because we are needed in many different areas, as you can see here, right? So if you are interested to join our technical division, more than welcome. As long as I'm the chair, I'm very much open to interest, right? So yeah, 4 years ago, 2019. I'm sure some of you are in this photo as well, right? So I gave a talk right here in 2019. I think Mr. Kasi was in. Yeah, that time I think your lead was Prof. Leong, and yeah, Miss Aziza. I'm not sure whether she's still around.
Not yet.
No.
No.
Okay, it's okay. 4 years, things happen, right? So, but students who are still in here and here, maybe you're in the final year, right? So 4 years gap. Okay, graduated. Okay, it's okay. Anyway, yeah. So that back then the topic was standards education. I think the MC introduced me. Yeah, I've been actively promoting standards education because I feel that our degree courses we lack of emphasis on standards, right? Because when we go out to work, we go into the industry, they speak the language that they speak is in standards, right? It's not about Ohm's law. It's not about the lecture slides, right? So I feel there is a strong lacking in this, especially in the universities in Malaysia, whether private or public. So that's why I get into this. So anyway, today's topic is looking into the sun. All right, I tried my best to look for the best image because this looks like salted egg yolk. But anyway, we make do of it lah. Okay, so looking into the sun, right? So unlike Mr. Arkam's presentation where you go very deep, I'll just go very broad. Okay, so hopefully we can stimulate more areas that we can collaborate, right? I believe that's the purpose of the conference, right? To initiate collaboration. Okay. Yeah. So looking into the sun. Obviously, if I ask you to look into the sun, if you follow what I say blindly, I think you will be blind. You'll be blinded in minutes, right? You'll suffer permanent damage to your retina because of the UV radiation, right? So that's why this title is just a gimmick, right? It's just to attract your attention, right? But anyway, the topic is really on the sun, right? Some disclaimers. I'm not an expert, right? But I enjoy exploring this new field of interest, and I'm a firm believer of ABC. So I know that some of you are sleeping. So, but if you are to prove that you're awake, right, at the end you know what is ABC, right? So for me to know whether you're still awake or not, yeah, at the end you know what is ABC, right? So yeah, I think before we go into the topic about the sun, we need to understand and we need to agree, right, with what Mr. Einstein has said before 100 years ago. Energy we cannot create, we cannot destroy, but we can convert, right? So with this understanding, I mean, what he said, we just believe, right? Same thing like gravity, right? We are standing here, we cannot see, but we feel that there's a gravity, so we just believe it, right? So anyway, yeah, you talk about energy conversion, right? If you notice, when do you all learn renewable energy as a subject in your syllabus, students? Yes, right. So when you learn about the subject, right, do you notice that we tend to split the topics to solar, hydro, right, biomass, wind, geothermal, OTEC, right? So we tend to split into these topics. But if you think about it, right, actually most of the renewable energy sources actually trace its origin from the sun. If you think about it, for example, the wind, right? How do we get wind blowing? Is when certain area is hotter than the other area. So there's a temperature gradient, and that's where the wind blows. But how can this place be hotter than that place? It is because of the uneven heating from the sun, right? So we get wind energy. Hydro as well, right? Our rainwater is our rain, where it falls, how it evaporates. They are all attributed and linked to the sun, right? Biomass, I don't have to say so much. Without the sun, there is no tree, right? So they need the sun for them to do the photosynthesis and all that, right? And of course, this image over here is the most direct form of solar energy that we try to use, right? We can make use of its heat, or we can convert it into electricity. Okay, so that is about a little bit of physics, right? After all, engineering is the application of physics, right? So, and we are going to focus more into this, right? So solar energy, we can get from there. We can also get from solar PV, and our focus of the day is actually the one to your right, solar PV. Okay, we are not going to talk so much about solar thermal, right? Yeah, we're going to talk about this. So mainly from cell to module to array. So you might be asking, so where is solar panel? So panel and module, they are used interchangeably. Okay. Yep. So just a bit of a history. It is always good to know a little bit about the history of whatever that we are learning. That will make us more appreciative of what we are learning, right? So I think 100 over years ago, right, this PV effect was discovered by Mr. Becquerel. And then fast forward to 1950s. But you see, this is the thing about research. We might be discovering something new, but for it to become commercial, for it to become very usable, very practical by everyone in the world, it takes years, right? It takes decades, as you have seen here, right? From the day in 1839 until 1958, 100 over years, then only the first patent of solar panel was filed. But still, that time, we don't see that many of it because it is so expensive, right? It is just patent filing. And it will, we have to wait until maybe 2000, in the year 2000 or 1990s. That's where solar panel starts to pick up.